question gives us 1 over the square root of 1 plus 2i, and we were asked to write that in standard form. So first of all, we need to work out what is 1 plus 2i. So I'm just going to sketch a very rough Argand diagram, where this is the real axis, this is the imaginary axis. So we'd have 1 on the x and 2 for the y. So we need to work out what is this angle here, the angle theta. So using our tan rule, we can say that tan theta is equal to opposite over adjacent, or you could write it as y over x. So in this case, theta will be equal to the inverse tan of 2 over 1. And remembering to put the calculator into radians, that will give you an angle of 1.107. Now we need to work out r, which is this length here. I'll label it as r. So using the square root of x squared plus y squared, my x value is 1 and my y value is 2. That gives the square root of 5, and that works out to 2.236. Now we can say that 1 plus 2i is equal to 2.236 cis 1.107, where I'm using the rule that z is equal to r cis theta. Now that we've worked that out, we can then say that 1 over the square root of 1 plus 2i is equal to 1 over 2.236 cis 1.107, where I've just substituted in the result we found before. And then using De Moivre's theory, I can write that as 2.236 to the power 0.5, and I just realised I left off the 0.5 here. Cis, and that will be 0.5 times my angle. So that then gives me 1 over 1.5 cis 0.5535. Now remember that cis is equal to cos, so 1.5 cos 0.5535 is my real part. And then my imaginary part is the 1.5 sine 0.5535. And that then gives me 1 over 1.28 plus 0.789i. Now, in order to be able to get rid of the imaginary numbers on the bottom, we need to multiply that by the conjugate. So for the conjugate, we change this plus to the minus. We do the same thing top and bottom, so that essentially we're only really multiplying by 1 because they cancel out. So on my top line, I'm just going to have the 1.28 minus 0.789i. And on the bottom we end up with, it's of the form a plus b multiplied by a minus b, so that gives you a squared take b squared. So we've got 1.28 squared, which works out to 1.6384. Take away the 0.789 squared works out to 0.622521 I squared. Now remembering that I squared is equal to -1, I can then substitute that there. So we get 1.28 minus 0.789i. And on the bottom we've got 1.6384 now plus 0.622521. And that gives me roughly 2.26. Okay, if we divide the real and the imaginary parts by 2.26, we get 0.566 as the real part, and the imaginary part is 0.349i. So that's our answer in standard form.